All right, everyone, let's practice a bit more with calculating with functions, okay? So we have written here the formulas of two different functions. We have the function f of x and we have the function g of x, and we have the formulas associated with them, okay? So let's say we were asked to calculate f of, let's say, 2, f of 2, okay? So let's remember what that means. That means we're going to plug in the value 2 wherever the variable x occurs in the function f of x. So to calculate f of 2, we're going to calculate 5 times x squared becomes 2 squared plus 3x becomes 3 times 2 plus 1. Okay? So now let's remember our order of operations and go through this one at a time. 5 times 2 squared, right? Well, 2 squared is 4, right? So this becomes 5 times 4, which is 20, right? Plus 3 times 2 is 6, so 20 plus 6 plus 1, right? Well, 20 plus 6 is 26, plus 1 equals 27, right? All right, let's try a couple more. Let me get rid of this here so that we have some room. There we go. Okay, let's say now we want to calculate. Let's just say f, whoops, that's not what I want. Just a minute. All right, let's say we want to calculate f of 5, okay? F of 5. And we're just going through this to make sure we remember how to do this and have some fluency with it. So this is going to be 5 times x squared. Now it becomes 5 times 5 squared, right? Plus 3 times x becomes 3 times 5 plus 1. Okay, that's going to be 5 times 5 squared. 5 squared is 25, right? So this first term becomes 5 times 25, which is 125, right? It's 125 plus 3 times 5 is 15 plus 1, right? 125 plus 15, that's going to be 140, right? Plus 1 is going to be 141, right? So what does that mean? That means that the value f5 equals 141. And of course, it means when we have the function f, when we input the value 5, the resulting output would be 141, and which would also mean if we decided to graph f of x on the coordinate plane, there would be a point on the graph, 5, comma 141, right? The many different ways that we can interpret a function. So let's get rid of all this here, and then let's do one more example with f of x, okay? One more example with f of x. Let's try something a little different. Let's say we want to calculate f of -1, okay? F of -1, okay? That becomes 5 times -1 squared plus 3 times -1, right? Plus 1. Okay, so what is -1 squared? Remember, -1 squared is -1 times -1. That's a positive 1, okay? So this first term here becomes 5 times positive 1, which is 5. 3 times -1. What's 3 times -1? That's -3, right? So we could write plus -3, right? Or we could just write -3, right? So this becomes 5 minus 3, and plus 1 stays the same. 5 minus 3 is 2. 2 plus 1 is 3. Okay, so now let's look at g of x. That's a little bit more complicated, right? And it looks like I erased a little bit of this here, but this should be a squared applied to the factor x plus 1. It's a little bit more complicated, but not that much. So let's go ahead and let's say we wanted to calculate, let's just do g of 1 for now to keep it simple. G of 1. So that means we're going to look at the formula for g of x, and wherever the variable x appears in that formula, we are going to replace it with the value positive 1. Okay? So this is going to become 3 times 1 plus 1 squared over 1 plus 4, right? Wherever x occurred in our original formula, we replaced it with the value 1. All right, let's take this a step at a time. That becomes 3 times 2 squared, right? 1 plus 1 is 2, divided by 1 plus 4 is 5. And that equals 3 times 4, right, over 5. And 3 times 4 is 12, and over 5 stays the same. And that's a perfectly fine answer. That means that g of 1 equals 12 over 5. Okay, let's do at least one more example. Actually, let's do 2 more examples with this one, and then you guys can try some on your own. Okay, let's try to evaluate g of 0. Another pretty simple one, right? G of 0. Well, wherever the variable x appears in our original formula, we're going to replace it with the value 0. This numerator is going to be 3 times 0 plus 1 squared divided by 0 plus 4. Okay, that becomes 3 times, what is 0 plus 1? Well, that's obviously just 1, right? So 3 times 1 squared over 0 plus 4 is just 4, right? 3 times 1 squared, that's just 3 times 1 over 4, and not much changed, right? Our final answer is going to be 3 over 4. So g of 0 has the value 3 over 4. Or if we have this function g, if we input the value 0, the associated output will be 3 over 4. All right, let's do one more. Let's do one more like this. All right, let's take it up at least a little bit of a notch. Let's do g of 7. Okay, let's try g of 7. Well, that's going to equal 3 times x plus 1 squared divided by, whoops, we don't want an x plus 1 squared because we're plugging in the value 7, right? That's going to be 3 times 7 plus 1 squared divided by 7 plus 4, right? So this is going to be 3 times, what is 7 plus 1? 7 plus 1 is 8. So this is going to be 3 times 8 squared divided by 7 plus 4, which is 11, right? So let's evaluate this numerator. 3 times 8 squared is 64, right? Divided by 11 still. 3 times 64, that's going to be 192 over 11. And that's a perfectly good answer. So that means that the value g of 7 is 192 over 11.